A light plane flies 450 miles with the wind in 3 hours. Flying back against the wind, the plane takes 5 hours to make the trip. What was the rate of the plane in still air? What was the rate of the wind? So, the very first thing that you want to do whenever you're faced with any kind of word problem is to write down the variables and the unknowns that they represent. So notice how I've written here that x equals the speed of the plane in still air and y is the speed of the wind. Now, when I read this problem, I notice that I really have three quantities at work here. I have a distance, I have a time, and I have a rate that's in question. So I have created this little chart down here to help me organize the information. And it's based on the distance equals rate times time formula, since those are the three quantities that my problem is related to. Notice how each column represents the distance, the rate, and the time, and then each row represents the trip with the wind, and the second row represents the trip of the plane against the wind. So my goal is to complete this chart, and the idea is that the chart will then lead me to the two equations that I need in order to solve the problem. So as I read the first sentence here in the equation, I'm given two pieces of information that I can insert into the chart very easily. I'm being told that the plane flies 450 miles in 3 hours. So I'm going to go ahead and put a 3 under the time column and a 450 under the distance column. And to fill in the rate, when we think about a plane flying with the wind, that implies that the plane is going to go faster than it would in still air because the wind is there kind of helping it along. So if we take the speed of the plane in still air and add the speed of the wind, we're going to get a larger number that represents a higher speed, and so the rate of the plane with the wind can be represented by this expression x plus y. Now, as we read on in the problem, we learn that flying back against the wind, the plane takes 5 hours to make the trip. So the time of the plane going against the wind is 5 hours, so I'm going to go ahead and stick a 5 under the time column. And then the distance we can assume is the same, since we assume that the plane is just making the same trip back again. Now, in terms of the rate, when a plane flies against the wind, we can assume that the plane is going slower because the wind is kind of holding it back. And so if we take the speed of the plane in still air and subtract the rate of the wind, then we get a smaller number, which represents a slower speed. And so the rate of the plane going against the wind can be represented by this expression x minus y. Now that we've completed the table, we actually have the two equations that we need to solve this problem staring us in the face. So let me rewrite this first equation, again based on the distance formula, and it's going to be 450 equals the rate of x plus y times the time of 3. And then I'll rewrite the second equation in a similar way. 450 equals x minus y times the time of 5. And then in order to use this system to solve the problem, I'm just going to rewrite it in a way that will make it a little bit easier for us to deal with. So I'm going to distribute this 3 and then switch things around. So I'm going to write it as 3x plus 3y equals 450. And then I'm going to do the same thing with the second equation. 5x minus 5y equals 450. So finding the system of equations that you need to use to solve the problem is often the most challenging step in these problems. From here, you can use either method that you prefer to solve. You can solve this system of equations by graphing, you can do it using the substitution method, or you can do it using the elimination method. So it's really a matter of just picking your poison, and as long as you do the process correctly, you should get the same answer either way. I'm going to elect to solve this system of equations using elimination. So to solve this system of equations using elimination, I'm going to multiply the first equation by 5, and I'm going to multiply the second equation by 3. And look what happens here. If I multiply the first equation through by 5, I get 15x plus 15y. And when I multiply 450 times 5, I get a result of 2,250. And then multiplying the second equation by 3 gives me 15x minus 15y. And when I multiply 450 times 3, I get 1,350. Now, when I add down, this is kind of where the magic happens here. 15x plus 15x yields 30x, and 15y minus 15y is 0. So the y terms actually cancel out, and 2,250 plus 1,350 is 3,600. So I can now solve for x by dividing each piece by 30, and I get a result of x equals 120. And then when I plug x equals 120 back into either one of these equations, I get a result of y equals 30. Now let's go back to the original problem and make sense of these numbers. So we got a result of x equals 120, and x was representing the speed of the plane in still air. So that actually is going to mean that the speed of the plane in still air is 120 miles per hour. And then we got a result of y equals 30, where y is the speed of the wind. So the speed of the wind then is 30 miles per hour.